Hi dear students. In last session we saw imperfections or defects in solids. In this session, we will learn electrical properties of solids. Solids show wide range of electrical conductivity, and accordingly they are classified into three categories, that is, conductors, insulators, and semiconductors. Their range is shown here. Metals and electrolytes are conductors, nonmetals and molecular solids are insulators, and metalloids are semiconductors. The atomic orbitals of metal atoms form molecular orbitals, which are so close in energy to each other as to form a band. If this band is partially filled, or it overlaps with a higher energy unoccupied conduction band, then electrons can flow easily under an applied electric field, and the metal shows conductivity. If the gap between filled valence band and the next higher unoccupied band is large, electrons cannot jump to it, and such substances behaves as insulators. In semiconductors, gap is small, and so they show some conductivity. Electrical conductivity of semiconductors increases with increase in temperature. Substances like silicon and germanium show this type of behavior and are called intrinsic semiconductors. The conductivity of these intrinsic semiconductors is too low for practical use. Their conductivity is increased by adding an appropriate amount of suitable impurity. This process is called doping. Impurities are of two types, electron-rich impurities and electron-deficit impurities. Silicon belong to group 14 of the periodic table and have 4 valence electrons. In silicon, each atom forms 4 covalent bonds with its neighbors. When doped with a group 15 element like phosphorus or arsenic, which contains 5 valence electrons, they occupy some of the lattice sites in silicon. 4 out of 5 electrons are used in the formation of 4 covalent bonds with the 4 neighboring silicon atoms. The 5th electron is extra and becomes delocalized. These delocalized electrons increase the conductivity of doped silicon. Here the increase in conductivity is due to the negatively charged electron, hence silicon doped with electron-rich impurity is called N-type semiconductor. When doped with a group 13 element like boron, which contains 3 electrons, electron hole gets formed. An electron from a neighboring atom can come and fill the electron hole, but in doing so, it would leave an electron hole at its original position. If it happens, it would appear as if the electron hole has moved in the direction opposite to that of the electron that filled it. Under the influence of electric field, electrons would move towards the positively charged plate through electronic holes, but it would appear as if electron holes are positively charged and are moving towards negatively charged plate. This type of semiconductors are called P-type semiconductors. Let's see the applications of N-type and P-type semiconductors. Various combinations of N-type and P-type semiconductors are used for making electronic components. Diode is a combination of N-type and P-type semiconductors and is used as a rectifier. Transistors are made by sandwiching a layer of one type of semiconductor between 2 layers of the other type of semiconductor and used to detect or amplify radio or audio signals. The solar cell is an efficient photodiode used for conversion of light energy into electrical energy. Large variety of solid-state materials have been prepared by combination of groups 13 and 15 or 12 and 16 elements. With this, we came at the end of session. In next session we will learn magnetic properties of solids. If you like this video, please give a thumbs up and share it with your friends, and do subscribe our channel and don't forget to click on the bell icon.